Welcome. In this video I'm going to show you how you can perform a one sample trimmed mean test, also known as a Yuen or sometimes even a Yuen-Welch test. Usually this is done with independent samples, but it can also be done with a one sample. Now I'm going to be showing you how this can be done with Python and my stikpetP library. Now this is a test which is a variation of a one sample student t-test where we actually used, as the name implies, a trimmed mean and actually also a winsorized variance. The assumption is therefore still actually the same, that the in the mean in the population is equal to a provided value, the mean according to the null hypothesis in full. There are actually two variations I've come across in how to calculate this, which will have a slightly different result. To show you how this can be done, I'll of course need some example data, so I'll load in pandas just so I can load in some example data. This data comes from the General Social Survey from 2012, and I've adapted it slightly for these example purposes. Now I actually don't need all the data, I just need one numeric field, and age seems to fit the bill. However, there is an 89 or older category, so I'm just going to replace those with 89. Perhaps I should replace it with something else, but it's just for an example. And I'm making sure that everything is numeric. So I'm going to store that under scale field, get the data frame, have my coding of 89 or older being replaced with 89, then of course use the replace function from pandas, and then make sure everything is numeric. So now I have my data stored under scale field, and I'm gonna set my hypothesized mean to 50. So this is a choice you make, like I want to test if the average age in the population could have been 50. Now my library you can install directly from my GitHub account, so you can't just use pip install and then stikpetP. You really have to link it to my GitHub account. Once you've done that, you can actually import it just as any other library. And the function of interest is ts, short for test, trimmed underscore mean, and then os for the one sample. Now it takes the data as input. The optional is the hypothesized mean, in our case that 50. If you don't set it, it will simply use the mid-range, which is the maximum plus the minimum divided by 2. You can set how much to trim. The default is 10%, which in total, which is then 5% from each side. The SE parameter is a string, which you can either set to UN or Wilcox, depending on which of the two variations you would like to use. Now, and that's all we actually need. So if I run this now, I get all the information I would actually need. Oh, I didn't actually execute my hypothesized mean, so let me do that first. And now, hopefully, I don't get an error. And it nicely returns a small data frame with various columns. The first one is the trimmed mean, then the hypothesized mean, then the standard error, the test statistic, which is actually a student t-value, so a t-statistic, the degrees of freedom, which is the number of scores that was used in calculating the trimmed mean, -1, and then the significance, also known as the p-value, and a small description of the test to use. The most important value is probably that p-value. If that is below 0.05, which is the usual threshold, then we would reject the assumption, and the assumption was that the population mean is 50. So in this case it's far below it, -07. I need to adjust the text a little bit. So in this case, this means I need to divide this 1.068 by 10 to the power of 7, which is extremely low. And that's how you can actually perform this test with the stikpetP library. I hope this video was helpful, and thank you for watching.